Number 6, we're going to find the y-intercept. The y-intercept is where the graph crosses the y-axis. So A, you could write it as y equals 0, because that y value is 0 there, or you could write it as the point 0, 0. Roots are where the graph crosses the x-axis. There are 3 of them. -6. This one's at 0. And this one's at 5. You could also write them as the points. -6, 0. X is 0 would be 0, 0. And then 5 would be 0, 0. Positive intervals are the sections of the graph that are above the x-axis. So it would be this section right here. So that would be between -6 and 0. And then this section over here, which is between 5, and then this graph keeps going and going and going, which means our x values go towards positive infinity. The negative intervals is where the graph is below the x-axis, which would be this section here and this section here. So this graph on the left, we don't know where it's coming from. So it's coming from negative infinity. And it stops being negative right here at -6. And then it starts being negative again here at 0 all the way to 5. End behavior always starts off the same way. As x goes to negative infinity and as x goes to positive infinity, which way does your graph end? So going to the left, where x is negative infinity, this graph never stops going down. So y is going towards negative infinity. As we follow to the right, this graph never stops going up, which means y is going towards positive infinity. Okay, number 7 requires a lot of things. I might need some more room to write here. Okay, y-intercept is where your graph crosses the y-axis, which is here. So for part A, our answer is 0, 0. For part B, roots, or where does our graph cross the x-axis? We have 3 of them. First one is -3. The second one is when x is 0. And the third one is when x is 5. I'm just going to kind of cross these out as I go. If you wanted to write these as points, you can. On your quiz, it's either going to be multiple select or multiple choice, so they should be pretty easy to distinguish. Increasing intervals are any parts of the graph that have a positive slope, which would be right here. So this x value is -1, and it's positive until we get, and I'm going to cheat and say that that's right on 3. That was my intention when I drew this graph. So -1 to 3. Decreasing intervals are the sections on your graph that have a negative slope, which would be these 2 yellow sections here. And you're going to use the x values. So this is -6 to -1. So part D is -6 to -1. And then from 3 all the way, this is going to keep going and going and going. If it keeps going right forever, it goes towards positive infinity. Decreasing. Positive intervals are the sections of the graph that are above the x-axis. So that's going to be this section right here. So for part E, The x values are from -6 to -3. Over here, it's this section, that's this peak, which goes from 0 all the way to 5. The negative intervals is where the graph is below the x-axis, which starts here and ends here. So f, those x values are -3 to 0 with square brackets. And then starting here, which is 5, and it keeps going right, which would be positive infinity. Relative max and relative min come next. So relative maximum is a maximum point, but not the highest point. So I tend to like to do absolute first. E, F, G, H, I, J. So absolute maximum is the absolute highest that this graph gets. So if you notice, this graph has a definite point right here. So that is the highest point. This would be your absolute maximum point, which is at -6, 9. So that would be I. Any other peak would be a relative maximum. So we have this other peak point right here, which is at 3, 6. That would be your relative maximum. And I'm sorry I'm going out of order. It's just the way my brain works. Absolute minimum is the lowest your graph goes. Well, if you follow this graph down and down and down and down and down, it never stops. So there is no absolute minimum. Any other minimum or valley point would be your relative min. So right here, you have a relative min at -1, -3. That fills these. You did absolute minimum. Symmetry, is there anywhere on your graph that you could fold it vertically or horizontally to make it match? The answer is no, so that's not applicable. And then lastly, end behavior. Always starts off the same way. As x goes to -infinity and as x goes to positive infinity. So as we follow this to the left, what happens to your graph? Well, your graph stops right here. So your y value only goes towards +9. It doesn't go any higher than that. As x goes to positive infinity, so as you're following your graph to the right, your y keeps going down because your graph has that arrow, so your y goes towards -infinity. Last one, number 8, relative maximum minimum. So relative maximum is if you have more than one peak point. We do not have more than one peak point. We only have one peak point. Since we only have one peak point, that would be your absolute maximum. So I'm going to skip around again. That would be -4, 8 for absolute maximum. Since we don't have another peak, like if it looked something like this, we would have two other relative maximums, but we don't have that here. All we have is that one absolute, so there is no relative maximum. Relative minimum, again, if our graph looked like this instead, these would be your relative minimum points, but all we have is this straight going down on each side, so there is no relative minimum. Part D, absolute minimum. On the left-hand side, following this down, it goes on forever, and so does the right-hand side. So that means there's no stopping point or no absolute stopping point. So this is also not applicable. So if it looked like this, let's say, and instead of arrows, it had dots, whatever the lowest point would be your absolute minimum. Symmetry, is there a line that you could fold this paper in half, left to right or up and down? Yes. You could fold it in half right here at the point x, at the line x equals -4. End behavior starts off the same way as x goes to -infinity and as x goes to +infinity. What happens? So x going to -infinity, we're going to the left. This keeps going down forever. So y goes to -infinity. On the right, following it down, or to the right, following it to the right, it keeps going down. So again, over here, y goes to -infinity.